Hi there. Welcome to your video notes 3.5. Today we are going to be creating equations from tables. So we are going to create equations from tables and we're going to graph from tables, creating equations from tables. We're going to graph data from tables. And then we're also going to talk a little bit about slope. So those are some of our topics for this video. You can title it 3.5. You can pause the video right now so that you can draw in your Cornell boxes. You can also pause the video to draw in this table over here. And then you need to sketch out a graph as well. Okay. We have another story problem. Jean runs 2 laps around the track in 7 minutes. The table below represents how fast Jean can run laps around her school's track. Assume she always runs at a constant speed. So the first thing that you're going to do, the first thing we're going to need to do is we are going to need to complete this table. So complete the table below because eventually we're going to have to graph this. And then eventually we're going to have to create an equation. So this is a very common thing that you are going to have to do many times over and over again. Complete a table, graph it, and then make an equation. And then be able to do all 3 of those things at once. That would make us very happy. Okay, completing the table below. Notice here in 2 laps, she can run 7 minutes. It takes her 7 minutes to run 2 laps. So if we divide that by 2, we divide 7 by 2 to go backwards, our ratio, our constant proportionality is 7 over 2 or 3.5. So I'm going to write 3.5. You can leave it as 7 over 2 if you want in here. So that means that for every lap that she runs, she's going to run it in 3.5 minutes. So that means if we multiply 3.5 times 2, we'll get 7. If we multiply 3.5 times 4, we should get 14. So with our calculator, let's see if this will pop up. Whoa, let's turn off that sound. Okay, so if we have 3.5 times 3, we should get 10.5, which makes sense because 7 times 10.5, or 7 plus 3.5 is 10.5. Okay, if we add that 3.5 to 10.5, we should get 14. And if we add 3.5 plus 14, we'll get 17.5. So let's graph this now. So this equation, the center place right here, we are going to come back to that. Graph. This is Jean's speed. Okay, so this is going to be my x-axis, which is my independent variable. So this is going to be in laps. And then over here, let's see, I don't know if it'll work this way if I write. I don't know how this works. Okay, maybe right here. Whoa, okay, this is going to be in minutes. Wow. Okay, so this is my y. This is my dependent variable. I don't care. Okay, for 1 lap, let's zoom in right here. For 1 lap, 2 laps, 3 laps, 4 laps, 5 laps, 6 laps. We have up to 5 laps. So in 1 lap, she can run 3.5. 1, 2, 3.5. This is 4, so this is 3.5. Okay, in 2 laps, she runs it in 7 minutes. So over 2, I'm going to go up 3.5. Yeah, this is 7. And I'm going to go over 1. And again, I'm going to go up 3.5 to 10.5. And I'm going to go over 1 unit. And each unit on my x-axis, I marked as 2 boxes. That's how I scaled it. And then for 4th lap, you're going to go up to 14, which is right here. I'm going to go over this way. And then for my 5th lap, it's 17.5. So if this is 17, my 0.5 is right here. All right. So I'm plotting Jean's speed. And she starts at 0, which is important because if she didn't run any laps, it didn't take her any time as well. So the hardest part about this right now is I'm going to have to draw a straight line, which is very difficult to do with this tablet. Oh boy. Oh boy. I'm going to pause this and then I'm going to draw a straight line. Okay, I did it. I drew a straight line. So what this means is this straight line is proportional. There was a special proportion between the amount of time she ran over the number of laps she completed. So we're going to create an equation that represents how long in minutes in Y Jean runs for any amount X. So first thing I'm going to do is I'm going to declare my variables, which means, so I said the word declare, which means you are going to name or call out that your variable stands for something. So X's are going to be equal to laps, and then Y's are going to be equal to minutes. Okay. So we need to represent an equation that relates X and Y. And I want to bring you back to this special relationship here, 7/2. This was the first information we had. 7 is under the Y column. Our ratio is 7/2. 7/2. And what that's equal to, it's equal to all the Y values over the X values. And sure enough, this is a really important relationship, the idea of the Y values over the X values, this change in Y over this change in X. You might have heard that before, but it's extremely important in most of your math that has anything to do with lines coming up. So Y's are going to be your minutes, and then X's are going to be your laps. And my Y value is 7, so Y over X. How about I change these colors here? How about I make it green? Okay, so X is 2. And then, okay, so my Y over my X. Now, this is almost an equation, but we want to write it in terms of Y. So we want Y equals. And to move this X over, this is Y divided by X. So here, to undo, already here, we need to get Y, isolate Y by itself. So Y is divided by X. Whoa. To undo this and isolate Y, we need to multiply both sides by X. Okay? So that's a really important concept as well. And if we multiply by X on both sides, X, and we multiply by X on both sides, then this X and this X will go to 1, and 1 times Y will be left with Y is equal to 7/2. This will simplify down to 3.5. You can leave it as 7/2. And we're multiplying it by X as well. X. There we go. Now we have this beautiful equation. This is kind of like the milk gallons problem, and any kind of money problem. The only thing that's really different here is the way I set it up first as a proportion, and then I multiplied both sides by X to isolate Y. This way I have this beautiful equation here that is not necessarily a whole number right here. Fractions and decimals, it is okay here. Or okay here. Just want to name that up, okay? That's the first part of this video. We're going to use this idea in the next part below. So the next part of your notes is, this is actually a good time to write your summary, summarize the 3 ways that we represent the information here. There's a table, a graph, and an equation. And then you can move on to maybe your next page, because we are going to talk about slope. On a new piece of paper or a new page in your notebook, or if you just continue onto your notebook, we're going to talk about slope. And slope here is going to tell us a lot of information about the relationship between 2 quantities. So in the previous example, we talked about the difference between number of laps and the minutes that are involved. In this, I just want to show you what slopes look like. Now, slopes are going to be slopes tell you the steepness and direction of a line. Okay, slopes tell you the steepness and direction of a line. So when I ask you to describe the slope, you can talk about how steep it is. You can also talk about the direction. So for the first top of these 6 slopes, we're going to talk about these are all going to be positive slopes. Positive slopes. And positive means that it's going to be increasing. So as the numbers, as we go from left to right, as we read from left to right, the value, the y value is going to get bigger. That's what that means. So we either have this value, this slope here. I'm going to run it right through. We may have this slope here, like this. And we may have something that looks like, whoa, that's fine. It does not have to go through the origin. Something that looks like this. So this will have a greater, this slope is steeper, also known, the value of the slope is greater. Whoa. And it's also positive. This slope is equal to 1. 1 is like a very neutral slope. If it goes exactly, if it cuts exactly between the axes, it's going to have a slope equal to 1. So usually that's pretty neutral. I'll ask you, is the slope bigger than 1, equal to 1, or less than 1? So in this case, this slope is equal to 1. This slope is greater than 1. It's greater than 1. And then this slope is going to be less than 1. This slope is less steep. The value is less than 1. Okay. Now, these slopes down here are all going to be negative. Okay, so we have something that looks like this. We have something that looks like this. This should hit the origin. Let's call it hitting the origin. And then we have something that looks like this. Really straight lines. It's hard to make a straight line on your computer with this tablet. Okay, let's talk about this. Da, 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 da. All 3 of these green slopes are less than, or they're negative. They're all negative. So this one is going to be this slope is steeper. The value is less than -1. Oh, yeah. So this value of the slope could be -2 or -3 or -3.5, but it's less than -1 on the number line. Let me just draw a number line here so you guys are pretty clear about this. Okay, here's 0, and here is 1, and here is -1. And over here is -2, and over here is +2. Okay, so when I say it's less than -1, I'm saying that it's like -2 or -3. Okay, over here, the slope is equal to -1. Also pretty neutral, it's just negative. It's equal to 1, but the negative version, and it goes right through. It goes right through the origin. It cuts the axes in half if this continued. If this continued down like this, and like this, okay? And then this slope over here is also negative. This slope is less steep. The value is greater than -1. So if we're looking on our number line over here, this slope will lie somewhere in this range. Okay, so it's going to be it's going to be less than 0 because it's going to be negative, but it's going to be bigger than -1. So it might be like -1/2 or -1/3 or -3/4. It's going to be along that line. Okay, let's see. Positive slopes look like this direction. They go this way. And then negative slopes go the other direction. And then creating an equation from slope. In class, we're going to talk about how to create an equation from slope. And I'm going to call on this idea of our slope in this case is our proportion. So in this case, if we go back to your notes, like flip back, 7/2 is our constant of proportionality. It's also our slope. It is also our slope. So now what I could do is I could redo this whole video and I say, you have your slope, y/x is equal to your slope, m, and then make an equation from that. It would be the same. We would have the same video, except every time I said 7/2, I would just say the word slope. So now I'm going to go back here. I want you to, again, summarize your notes. I want you to make sure you have all these. This is really easy for me to look at your notes and check if you have this done. Summarize your notes, fill in any big ideas, and then get your notes checked tomorrow. Bye.